Hello friends, today I am going to discuss another type of scheduling algorithm, shortest of first serve. Shortest of first serve is one of the shortest of first serve is one of the scheduling algorithms of CPU, which allows us to add the process in the CPU, which is a shortest amount of time. Coming to average waiting time and turnaround time of SFA, it is smaller than the first come first serve because FCFS leads to the convoy effect. In SJFS, it won't support convoy effect. Let us understand the problem for shortest of first serve. Before solving this, let us draw Gantt chart. In the initially there is a zeroth process for the process P1. It among these four, P3 has the shortest mm, burst time. Add one in the next three, P1, P2 and P4. P2 has the shortest time. Assign P2 to CPU. Add it will be 3. Among these P1, P4, P1 has the shortest job. Assign 8 with this because 3 plus 5 become 8. Add P4, it will become 17. Now we can calculate average waiting time. Before calculating this, first try to find out total. Waiting time is equal to starting time minus arrival time. First, try to calculate the waiting time for each and every process. First, we calculate the average waiting time for process P1. P1, the starting time is 3. The arrival time is 0. It will be 3. Coming for P2, the P2 process entered in 1 millisecond. 1 minus 3, it will become 1. Coming to P3, the P3 process entered in 0 millisecond. It will be 0. Coming to P4, the process P4 entered 8 millisecond. 8 minus it will be 0. First calculate the total waiting time. It will be 12 millisecond. Average waiting time will be 3 millisecond. Let us calculate turnaround time. The formula will be waiting time plus execution time. Let us calculate turnover for time for each and every process. The process P1 waiting time is 3 millisecond. The execution time is 5 millisecond. It will be 8 millisecond. For the process P2, the waiting time is 1 millisecond. The execution time is 2 milliseconds, 7 millisecond. For the process P3, the waiting time is 0 millisecond. Execution time is 1. It will be 1 millisecond. For the process P4, the starting time is 8 millisecond, waiting to 8 millisecond, and the execution time is 9 milliseconds, 17 millisecond. Let us calculate the total waiting time. Sorry, for the process P2 it will be 3 millisecond. Coming to total waiting time, the total waiting time will be 29 millisecond. Let us calculate average. The average will be 29 by 4. It will be 7.25 millisecond. Let us teach another example also. In the previous example, the arrival time is 0. Coming to this example, the arrival time is given with the values. Coming to this problem, don't confuse. Let us draw one Gantt chart. The initial is 0 millisecond. Among these four, don't concentrate on burst time. First, concentrate on arrival time. Whenever the process enters the first try to take a 0 millisecond because it arrives a shorter time. Initialize P1 to CPU and the burst time is 5 millisecond. The process P1 is completed. Now the process is in 5 millisecond. All the three processes are entered in the CPU. Among these three, the next don't concentrate on P1, concentrate on these three. Among these three, the shortest time is P4. Assign it to CPU, the time is 6 millisecond because 5 plus 1 is 6. The P4 is completed. P2 and P among P2 and P3, the P3 has shorter time. The P3 assign it to 8 because 6 plus 2 is 8. Coming to process late last process P2, it will be 17. Let us calculate waiting time. For each and every process. For the process P1, the starting time is P1 0 millisecond because it entered as 0 millisecond. The arrival time is also 0. Starting time is 0. Arrival time is also 0. It will be 0 millisecond. For the process P2, the starting time is 8 millisecond. It enters at 8th millisecond. The arrival time is 1 millisecond. It will be 7 millisecond. Arrival time don't give a 0. Look at the table and substitute. For the process P3, the starting time is 6 millisecond and the arrival time will be 2 millisecond. Total will be 4 millisecond. For the process P4, the starting time is 5 millisecond and the arrival time is 3 millisecond. It will be 2 millisecond. Let us calculate the total. Total is 13 millisecond. Let us calculate the average. 3.3 something millisecond something. So let us calculate the turnaround time. It will be waiting time plus execution time. First, we have to find out turnaround time for each and every process. For the process P1, waiting time is 0 millisecond. Execution time, don't confuse, it is same as a burst time. That is 5 millisecond. Total is 5. For the process P2, the starting time is 7 millisecond and the execution time is 9 millisecond. Total is 16. For the process P3, the waiting time is 4 millisecond. Execution time is 6. For the process P4, waiting time is 2 millisecond, execution time is 1 millisecond, 3 millisecond. Let us calculate the total. Total 30 millisecond. Average 30 by 4, 7.5 millisecond. Shortage of also may be preemptive or non-preemptive. When the SJFS is non-preemptive, it is given directly to the process. Whenever the SJFS is preemptive, it perform context switching. That's all about the concept. If you have any doubt, please drop the message in the chat box. Thank you.